Hello everyone, we got the properties of logs for Algebra 2. There are three properties that you're going to be introduced to, and the first one is for a piece of vocabulary, if I had the square root of 3x minus 4 plus 12. The 3x minus 4 is inside the square root, and that's called being in the argument of the root. So this 5x is in the argument of the logarithm. It's inside it. So when you have a product in the argument of a log, you can break that logarithm into two separate logs that's adding. So when you're multiplying, you can break the log into two parts that are being added. When you're dividing, you can break the log apart into a difference. And when you have an exponent inside a logarithm, you can drop it down in front as a coefficient. Okay? So here you have a product inside a logarithm. So I can break it apart into a sum. So that's log of 5 plus log of x. Here you have a quotient inside a logarithm, so you can break it apart into a difference. What's on top comes first, and what's on the bottom comes second. This, I'm trying to trick you. It's when your fraction is inside the logarithm, not a fraction of logarithms. Okay, so this one can't go any further. It is what it is. This, you guys know, a square root can be written as an exponent. So then this is going to drop in front as a coefficient. So that becomes 1/2 log x. All right. Similar idea here. This is log of 6 to the 1/3 power. That's going to drop down in front. So you have 1/3 log of 6. This one I'm trying to trick you again. This is a difference inside a logarithm. There isn't a property for that. So that's as good as it gets. This exponent's going to fall in front. And this one, definitely longer. I'm going to focus first on this fraction that's here. So I'm going to break it apart into a difference. So it's log base b of x squared minus log base b of y squared z cubed. Okay? Now, it's not done. This has a product inside this logarithm. It's inside it. And be careful of the subtraction here. It's subtracting everything that comes after it. Okay? So, when you write it, you're going to have log base b of x squared minus, and I'm going to put a paren to keep it all together, log base b of y squared plus log base b of z cubed. Now that subtraction is going to distribute through. So you have log base b of x squared minus log base b of y squared minus log base b of z cubed, and now all your exponents are going to drop in front. So your final answer is going to be 2 log base b of x minus 2 log base b of y minus 3 log base b of z. Okay. Now I'm going to erase that so then I can do these next problems. Here, what they're looking for you to do is work the problem backwards. You have a difference of logarithms, and in order for you to bring these together, the bases have to be the same. Let's say, for example, this was a 3. I couldn't use the properties. The bases have to be the same to do it. So this would come together, log base 5 of 125 over 5, which is log base 5 of 25. And I'm hoping that you guys can start to look at these and go, oh, I recognize what the answer is for that. 5 to what power is 25? Or you could pronounce it this way. What is the exponent on 5 that gives you 25? Oh, 2. Bring this together. Log base 5 of 150 over 6 is the same thing as log base 5 at 25, which from what we just did, 5 to what power is 25? Or what is the exponent on 5 that gives you 25? 2. 5 squared. Okay. Same idea, you're subtracting, so divide. So you're going to have log base 4, that's a heck of a 4, of 2 over 8, which is log base 4. I don't know why it closes my 4s. I know my penmanship's awful, but come on. Of a quarter. Now, to help you see it, that's saying 4 to what power is 1 over 4. And I hope you guys remember that that's going to be x is equal to -1. 4 to the -1 is a quarter. Okay? So let's see. One of the things that the reason I'm hesitating here is because this brings up I guess I'll call it a special case. This is really saying log base e of e cubed. That's just this first piece right here. What I want to do is, how about I write it without e's, so you guys are a little more comfortable with this idea. If I said log base, I don't know, 5 of 5 squared. This is asking, what's the exponent on 5 that gives you 5 squared? Oh, 2. Or say it another way, 5 to what power is 5 squared? Okay, the answer is 2. So what I want you to see is when the base of the logarithm matches the base of the argument, they cancel out. Okay? When the base of the logarithm matches the base of the argument, they cancel out. So the ln of e cubed is 3 minus the ln of e to the 7th. Those cancel out and you get 7. Your answer is -4. Okay? Let me move this piece out of here. Okay. All this is saying is use the properties, so stuff the half back up, and you have log of 4 to the half. Well, that's saying the square root of 4, so that's really saying log of 2. Okay. Put this back up. Log of 4 to the 3 halves. Remember, that's a root, so the square root of 4 is 2, so this would become log of 2 cubed, which is log of 8. Okay, so that would be your final answer right there. You're not solving it, you're just using the properties, pushing it back, and simplifying it. Okay, here, these would pop back up as exponents. Nothing pops back up there. So you have log of x squared plus log of y cubed minus log of z. Now when you're adding, it becomes a product, and when you're subtracting, it becomes a fraction. So you have log, and this is all going to be inside, so that'll be x squared times y cubed divided by z. Okay, so you're done, you're finished, nothing else happens to it. This, just do the work inside, log base 5 of 5, and I hope you're going 5 to what power is 5? 1. Or what's the exponent on 5 that gives you 5? 1. Okay. Here, you have a product of logarithms. There's nothing you can do. I'm just trying to see if I can, I don't want to say trick you guys, but see if you're paying attention. Okay, if this was a sum, you could bring it together, but because it's a product, there's really nothing you can do. Okay. Here, they're just trying to see if you can use the properties of logarithms. They've gone ahead and found 3 to what power is 5. So 3 to the 1.465 equals 5. And 3 to the 1.262 is equal to 4. All right, about those 4s. Like that 4 inside there too. All right. So what they've done is they've done that work for you ahead of time, and what they're saying is, using the properties that you've been doing on the previous page, use this information to get an approximate answer for it. So log base 3, I need to rewrite 20s in terms of 5s and 4s, so I can use what those values are worth. So although 20 is 2 times 10, it's also 4 times 5. So I'm going to use the 4 and the 5 because that's what's being referenced here. I have a product in the logarithm, so it's log base 3 of 4 plus log base 3 of 5. And log base 3 of 4 is worth 1.262 plus log base 3 of 5 is 1.465. And now you just add those together, and that would be your final answer. Here you're dividing, so you have log base 3 of 5 minus log base 3 of 4. They tell you log base 3 of 5 is worth 1.465 minus what log base 3 of 4 is worth, 1.262. And then you do that subtraction, and that would be your final answer. Here, drop the 2 in front. 2 times log base 3 of 5. And log base 3 of 5 is worth 1.465. 2 times 1.465. And gives you an answer. Okay? So, doing that same idea down here, you have a product inside the logarithm. So it's log base 3 of 4 plus log base 3 of 4 plus log base 3 of 5. So that's 1.262 plus 1.262 plus 1.465. Add those up, and that's your answer. This one would be log base 3 of 4 minus log base 3 of 5. So that's 1.262 minus 1.465. You're just filling in what these things are worth based on the information above. Drop the 5 in front. 5 times log base 3 of 4. So that's 5 times 1.262. Get an answer for that, and you're done. Okay. I think that's the last screen. Yep. There you go. Come on.